You're very welcome back. Today we're studying sum difference and factor formula. Okay, and you'll get to that pretty quickly if you it's just right out near the end of your book, chapter 17, if you're trying to find it pretty quickly, if you're not using a bookmark. Okay, now and the next thing is we were going to refer to it's going to be page 15. So this is just a little game I was referring to. So basically, an observation is that the dead center of your book is at 48. Okay, so what's 48 divided by 3? 16. Okay, so we're going to about a fifth of that, which is actually a tenth of the way into your book. Now, you might think I'm being absolutely mad, but I think it's a fun little game to try and eyeball a fifth of the way into a half. So just when it comes to finding it, and another thing is you can surely always go to your contents and look up trigonometry, but okay, which is page 13, but then you're going to realize you have to go 2 pages forwards from 13. So you're just going to I'd like you to get to know the locality of trigonometry. Do you have a guess? You turn it up. No, I got it that time. But always when you're on so basically when you're on a page, when you're under pressure and there's 3 minutes left in an exam, you can panic and start turning pages in your log tables and you don't know whether you're going forwards or backwards. So get to know your local environment. Okay, so get to know that basically the trig starts here with the unit circle and the special angles results for the trig functions. Get to know that page. That's the opening page of trig. Then you're going into what we're talking about now. Okay, recently we just did the double angles and the compound angle formulas. So now we're going on to and just before just to continue on the next page. So if you've got cosine, sine rule, SOHCAHTOA and Pythagoras. Okay, and indeed the area of a triangle. Okay, and after that it's not trig anymore, it's vectors, which are more or less gone off the course. And then we're on into coordinate geometry, which we're doing next, by the way. So basically you know that if you're on sine cosine rule and you see triangles, you're gone too far and you want to go back. And if you see the unit circle, you want to go forward. That'll mean you'll be rapidly finding your way to this page. Okay, now before we get started on using these formula, I want to concentrate on the name of this page. Okay, so it's been called a product, going from a product to sums and difference. So just a reminder, sums means you get sums when you add things together, and you get differences when you subtract things from each other. Okay, and the word product comes from the fact that these are products. They're actually double products, if you like, and it might be absolutely no harm to write in double products instead. Okay, so another interesting thing is, and this is going to connect out to a different topic. This is going to connect out to the counting, probability and statistics, and our counting course. And you say, just ask you a simple question: how many formulae are there here? Okay, yes, we can all count. The answer is 4. And if there's 4 here, what is changing? We're going to study the change here and what is going on. So notice that if you have a cosine, their cosines come together. They come together in the first and they come together in the third. And if you have a sine, the sines come together. So we can do a thing called a two-way table here. And we can just basically say, which sinusoidal is it? And it's either going to be a cosine or a sine. Okay, a choice of 2 things. And the other thing, what else varies here? And the other thing that varies is it's either the sum or a difference. Okay, so So basically, or it's addition or subtraction. So we'll basically say, what's the summation? What type of summation is going on? And you have adding going on or subtracting going on. So you have basically you have four different options. You basically have, if you were to randomly pick one of them, it's either a cos or a sine. And how many ways can you randomly pick a sinusoidal function? 2. And how many ways can you pick the middle action? And it is also 2. There's a washing machine going on there I have to turn up, but I'm going to keep this recording. Better things to be doing now than editing videos. Sorry about that. Okay, so that's interesting. So that's so we either have plus or minus in the middle, and we either have all cosines or all sines. But on the right hand side, you do not get a mix. On the left hand side, you certainly do get a mix. Okay, now so that's that, and you could start learning them off, but there's no big deal because you're always able to go to this page. Now regarding this question which we did in class, I want to revisit it. Now you know we discovered at the very end basically a kind of I went about it in a roundabout way in terms of I did a lot of algebra and so on. We could have done this more directly by recognizing that the bottom of this page is basically a kind of the reverse of the top of the page. So if we have products on the left here, we have products on the right here. Okay, and simply just A and B play a different role. The A that we see here is really acting as this sum. So basically, you know, you've sort of swapped them out and they play a different role. But other than that, we had kind of derived all these equations by just dealing with simultaneous equations such as A plus B equals something and A minus B equals something. We didn't have to. That's the long and the short of it. So what we could do is the moment we see that we're dealing with a difference, and of course we know that difference is only going to be sines or only going to be coses. It's not going to be a mix. Then, so when you're dealing with the difference of two sines, different arguments, then you know that you can go straight to the bottom of page 15. Okay, and you can figure out which one. There's two possibilities, like I showed you that two-way table. So there's two possibilities for subtraction of sines, and so this is the one you want to focus in on here. And so we're focusing in on this, and you're going add the two numbers gets 8x over 2. So that's exactly what this is telling us to do. So let's just write down the formula. The sine, this formula here, the sine of A minus the sine of B is equal to the sine of the average of the two numbers times the sine. I made a mistake there. That should have been 2 times sine of an angle minus the sine of the another angle is equal to double the cosine of the sum, cosine of the average. Is that correct? Yeah, cosine and times the sine. And do be careful. Obviously, you've seen me make a little bit of a blunder there, and if I can make a blunder, anyone can make a blunder. Ha ha ha. So basically, do be careful. We can end up going into autopilot, and our eyesight or something can let us down, and we're seeing so many sines and cosines you can mix them up. So genuine mistake that you want to avoid. We're going to have a policy to always put the big angle first, so we won't end up with negative results here when we've done the subtraction. We'll avoid that like the plague. So 6x take 4x. Just one other thing on parity: if they're both even or if they're both odd, these things will either will also be even or odd. And if these are mixed, and it's called parity. Parity is a way of discussing whether things are even or odd. And so if the parity is mixed, if one is even and one is odd, then we will end up getting getting divided by 2, because this 2 won't distribute in after doing the top operation. See what I mean? As we practice them, I'll revisit that. So 6x take 2x is 4x, and half of 4x is 2x. Okay, so, and sorry, I'll just write it as it's said here first. But we also need vocabulary. We need to be able to say this in plain English. So double the cos of the average times the sine of half the difference. There's no easier way of saying it. You could have called this half the sum, but half the sum is just, we have a very special meaning in statistics for that. It's called the average. Whereas half the difference doesn't really have a particular meaning, so we'll just call it half the difference. But if you wanted to resonate and to sound, to have similar expressions, then you could avoid saying average, and you could learn off the difference of signs is equal to double the cos of half the sum times the sine of half the difference. But probably not worth, at the end of today's lesson we decided, I think we had all discovered that it's really not worth the effort. Just for Leaving Cert anyway. If you're going on to third level maths, then you might want to, certainly we can write that down. The difference of sines is double the cos of half the sum times the sine of half the difference. The difference of sines. Okay, let's get down to some work. Okay, so from now on we'll just use an actual book of log tables because I've written all over those ones. So what you have here is you're working off the top directly, and you're finding there's only one of 4 that have this pattern, cosine cosine. So cosine cosine, double cosine cosine is this top one here. So we're simply going to write in the answer here for this. Actually, let me see. Let me get this going over the full page here. Right. So I'm going to get cos of the sum is the cos of 8x plus cos of the difference, which is the cos of 4x. So we've written it as a sum. On to this one. Double the sine, so you find sine on the left hand side here, double sine. So it's the cos of the difference, and you make sure big is for up front. So we're getting the cos of the difference minus the cos of the sum. Okay, it's 2 done. Moving on to 3, we'll do 3 in this in the middle here. So double cosine cosine. Well, it's still in the same place as it was a second ago. Handy out. The cos of 4 theta plus the cos of 2 theta. Okay, going down into a mix, but this is not a good mix. It's not very handy, this mix, because the 7a is at the end. So we'll change that into double the sine of 7a sine of 5a. That way we can avoid dealing with a negative argument towards the end. So it's a sine, so we're looking for a sine here. That's this one. And what's happening here in the log tables is an integral part of what's going on here. So this is the way you model yourself and think about how you'll be acting in the exam. You'll be very closely checking that these match. You'll be keeping your finger on this, and you'll be bringing your finger across here. And so you're going to cos of the difference. What's 7a take 5a? 2a. So it's the cos of 2a. Moving my finger, minus. keep going here, add them. What's 7a and 5a is 12a, and it's the cos of 12a. You have a lot going on. You could mix up your cosines and sines. You could make a mistake in the arguments, and you could make a mistake in your sign. So slowly and carefully working across that page there. Down to the bottom of these ones. Now, what's wrong with this? We don't like it because we want the sine of 6x at the beginning and the cos of x at the end. Quickly looking for that, we need sine cos. Now, there's something else wrong with it. Sine cos, it doesn't have a 2 at the beginning. So we, like I said, we'll want to drop that 2 underneath. It used to be supposed to be up there, so we drop it underneath. Cool, we're good. Except I can see that I'm going, because of the way the question is phrased, I'm going to have to distribute the division, which I might as well do up front rather than write down something that I need to change. In other words, whatever this gives me, I'm going to have a 2 underneath it. And I can see, and just double checking here, this is sine, cosine. So I'm coming along here and I'm getting the sine of whatever I get when I add them. And I'm popping that 2 down there because that's just what I have to do. And we're going to repeat that division by 2 over here. So I'm getting the sine, very carefully, the sine of 6 take 1, sine of 5x over 2. Now I just want to see, because I have the more answers here. So we've done just done question 5. Now technically they didn't express each of the following as a sum or a difference, so we won't give them full marks for that at all. Okay? Because they expressed it as a product. Okay? So they took their eye off the ball and they weren't meticulous about the wording. And in maths we have to be meticulous. Attention to detail knows no bounds when it comes to maths. The way we think. We live and die by definition. Okay, in maths we just get everything has to be exact. That's the way maths is, unless you're doing probability and statistics where there's randomness. But